right, this video is going to go over Unit 6 Lessons 2 and 3, where we're reasoning about context with tape diagrams. So today we're trying to do two things. We're trying to go from a tape diagram to an equation, and also go from an equation to a tape diagram and try to model our relationships both ways. So looking at a problem here, if a school has 46 copies of a popular book and then the library takes 26 and the rest is split evenly among 4 teachers, you're trying to solve a problem like how many books does each teacher receive, you could set this up with a tape diagram. 46 would represent the total, and in that you would split up the 26 that the library gets and 4 equally spaced boxes that are each labeled X, or whatever variable you have of your choice, because 4 teachers get the same number of books. In your Ed puzzle, I'm going to ask you to write an equation for this and also to solve it. You're also going to work with some other scenarios that are similar, but they have subtle differences. I'm going to show you the tape diagram for this problem. I want to talk about why we have the 9 in each box. So in our problem here, it says there were boxes of 4 for the shipment, but a new design increases the weight of each sensor by 9 grams. So it's not just 9 grams that are increased once, like in that library, taking 26 one time. Every single box has that extra 9, so we model everything by x plus 9, etc. Okay, again, I want you to think about how you could model this with an equation, and also go ahead and try to solve it. All right, and sometimes instead of a context, I might just give you a straightforward equation like 3x plus 15 equals 45. Why don't you take a moment and see if you can model that? So in a tape diagram, you're going to have 3 boxes that each have a value of x to represent our 3x. If we add 15, we could put that together, and then you can have a bracket that shows your entire total is 45. All right. How about if I give you a tape diagram and ask you to write an equation? I want to talk about a few ways that you might do this. So one thing you could originally do is just notice that altogether these add up to 60, these components. So you might just write 24 plus x plus x plus x plus x equals 60. Or you might try to shortcut it a little bit and say 24 plus 4x equals 60. Or maybe you're even thinking about the solving for x and know if you have that entire 60 across the top and you take away the 24 that are here, then you're left with equaling 4x. So you might say 60 minus 24 equals 4x. Another tape diagram. Go ahead and think about different ways that you could write this as an equation. So again, you may have just straightforward said, I'm adding 3 plus x plus 3 plus x plus 3 plus x plus 3 plus x, that equals 44. Or maybe you noticed that there were 4 groups of 3 plus x, so you did 4 times the quantity 3 plus x to equal 44. Or maybe you kind of added up the individual components and noticed that there were 3, 3, 3, and 3 made you 12 plus 4 x's equaled 44. Or maybe you did 44 divided by 4 and noticed that one of those sections was equal to 3 plus x. Again, there are a few other ways to write this problem too, but these are probably the most traditional. Again, do you feel comfortable both starting at an equation and making a tape diagram, and also matching both equations and tape diagrams for a word situation? I hope you can say, yup.